Hey y'all, today's objective, this is scale drawings and scale factors. Scale drawings and scale factors. You're going to have to excuse my voice, so I might do a little cracking today because I don't know, my voice has just been weird. But you will need a calculator, so pull one up on your computer or your phone, and then here's the vocabulary. I have to go get a calculator, so pause it to get the vocabulary, and then I'll explain. Okay, so scale is the ratio between two measurements, is the ratio. So that's word is in purple, that's important, the ratio between two measurements. A scale, for example, might be, if you're looking at a map, and the map of North Carolina, so North Carolina might be this long, obviously that's not the real accurate length of the state of North Carolina. So it might be 1 centimeter is equal to 50 miles, or something like that. So that is a scale. That's an example of a scale. Scale factor is used to enlarge or reduce a figure. Enlarge or reduce. So that's called a scale factor. If you ever want to make something bigger or smaller, you're going to use a scale factor. And then a scale model or scale drawing. Model, like a model airplane or a model building. And then a scale drawing is a proportional figure or picture of a 3D object. And the word proportional, underline the word proportional, that's important to know. And here are some examples. Models, maps, blueprints, pictures, lots of things are scale drawings or scale models of the real thing. Alright. Example 1. A map scale is 4 centimeters is to 30 miles. That's your ratio. 4 centimeters is equal to 30 miles. Find the missing distances. So on a map, 4 centimeters and 30 miles. The map distance is the 4 centimeters because the centimeters would be on a map. The 30 kilometers, did I say kilometers or miles? But the 30 kilometers would be the actual distance. So we have three problems, A, B, and C. 2 centimeters would equal how many kilometers? So we're going to set up a proportion. You start with your scale. 4 centimeters is equal to 30 kilometers. And then I need to put in 2 centimeters. Well, we know we're going to put 2 centimeters on top and X on bottom because you have to keep your centimeters together and your kilometers together. So you solve that proportion, you cross multiply. And that gives us 15 kilometers. Oops. Almost dropped my calculator. 15 kilometers. So let's do B. 75 kilometers is equal to how many kilometers? Is that map or real? That is real, so we're looking for the map distance. I start with my scale. See right here, start with your scale. And then where am I going to put 75 kilometers, top or bottom? I'm going to put it on the bottom. And there's X. So now I solve that proportion. 4 times 75 divided by 30. And that is equal to 10. So 10 centimeters is equal to 75 kilometers. So here's another one. 5.5 centimeters equals how many kilometers? So again, we have centimeters. That's on the map. So I start with my scale. Notice, I always start with my scale. Scale, scale, scale. 5.5 over X. Divide by 4. And we get 41.25 kilometers. So 5.5 centimeters is equal to 41.25 kilometers. And the key is using your scale, ratio, and then setting up a proportion. Alright, so example 2. Chris and James are building scale models. They completed a 4-inch long model for a car that is 15 feet long. So here's the model, and here's the real car. If a truck is 31 feet long, how long will the model be? So we're going to set up a proportion. And the first thing we do is we locate our scale. So let's talk about the one that was completed. 4 inches on the model, and that's equivalent to 15 feet. The other piece of information we have is this 31.5 feet on the truck. So where would that go, top or bottom? It would go on the bottom because it's feet. And we're looking for the model, so we're looking for inches. So you solve that proportion. And x equals 8.4 inches. So that would be the model, inches would be the small truck. And the real truck is 31.5 feet. So again, you start with the scale, and then you put in that third value, either top or bottom. All right, so example 3. Here we have a bedroom. The bedroom, 8 inches by 10 inches. Now, realistically, can you live in an 8 by 10 inch? No. So this is obviously a drawing, a scale drawing. So 8 inches by 10 inches. And then it says, what are the actual dimensions if the scale is 0.5 inch equals 0.75 feet? And we're looking for the actual dimensions. So dimensions would be length and width. So we're going to have to set up 2 proportions for this, length and width. So we come over here under length, and we use our scale. 0.5 inches equals 0.75 feet.
Good afternoon. This is last call for today's receipted money.
So I use my scale, and then I'm going to do length would be 10 inches. So I put 10 inches. So solve that. So this would be 15 feet. And then I need to do it for my width. So I set up my proportion. I use my scale. And then I'm going to use 8 inches, and that's going to go on top, because we have to keep our inches together. Now cross multiply. And this would be 12 feet. So the new dimensions are 12 feet wide and 15 length. So those are the actual dimensions of that bedroom, 12 by 15. All right, so example 4. A 4 by 6 inch picture is enlarged to a 14 by 21 inches. What is the scale factor? So this one, I've given you the small to the big, and we want to know the scale factor. So if you go back and you look at your definition, we're looking for the ratio. What is the ratio? How much did we increase it? So we need to set up our ratio. Since we enlarged it, we want to put the big one on top. So our ratio would be 14 to 4, because these correspond, or 21 to 6. Either one, you can use either one, but we're going to find the scale factor. So how much did it get bigger? So we want to reduce that. So you type that in your calculator. 14 over 4. And if you reduce it or simplify, you get 7 over 2, or 3.5, or 3.5. And so any of these, probably that one, but any of those would be the scale factor. So the question says, what's the scale factor? We enlarged it 3.5 times from here to here and here to here. So to double check, take your calculator and do 4 times 3.5. 4 times 3.5. And that gives you 14. And then do 6 times 3.5. And that gives you 21. So the scale factor is 3.5, 3.5, or 7 over 2. And I've just got my ratio. All right, so example 5, we have a living room. And we have a drawing of a living room, 3 inches by 5 inches. Obviously, that's a drawing. And the question, here's the scale. And the question says, what's the area? Now, area. You have to remember area in order to do this problem. So the area of the room. First, we need to find the actual dimensions. So we're going to set up 0.5 over 2 feet. And we can use 5. And then we're going to have to do 0.5 over 3. So this would be length. And this would be width. Just what we did before. So then you solve these proportions. So this would be 20 feet. And this would be 12 feet. I've cross-multiplied and then divided. So now I know that it's really 20 feet by 12 feet. But the question says area. So I'm going to leave that one for you to remember area. If you don't remember area, then Google it. Just type in, how do you find the area? And you can find it. Or go look in your math book or look somewhere and find the area of this rectangle. And then you can find the area of the living room. So we'll go over this tomorrow. And have a good day. I'll see you tomorrow.